All right, I said, let's go to the classroom, but instead we went to my living room. What we're going to talk about is how to triangulate. So maybe you want to write this down because these steps are going to be helpful when it's time for you to actually triangulate. So, title, should have put my name and date on the corner. What we were just doing outside was number 1, obtain measurements. So what measurements did we get? Well, first of all, there was a known baseline. My baseline was 54 meters. How did I know that? Well, actually, I used a trundle wheel to measure it. Following that, I need to know the angle from the baseline to the object of interest, which was the chair. I need to do this from 2 points of view, A and B. And remember, the difference in the backgrounds is called parallax, and that is what we are using to determine the distance to the object. The longer the baseline I have, the more accurate my measurements are going to be. So, what do we have? We've got 2 points. I know the distance is 54. And then I measured the angles. Angle A was 80. Angle B was 56. Okay, next step. This is what we did outside. The chair is up here, so I'm going to put a dot up there, and that's going to be data point C. The next thing we did was a scale drawing, or the next thing we do, which is what we're going to do right away. First of all, decide on a scale. Well, if this is my drawing, it's going to be 54 meters is equal to 5.5 centimeters. 5.5 centimeters, 54 meters. I don't like that very much. Maybe I would change that to 5.4 centimeters, just to keep the numbers a little nicer. Anyway, draw what you know. I just did that. Extend data points until they cross. Well, first of all, I'm going to need to get my compass out and measure this angle. And I actually kind of know an approximation. I'm going to extend the data points until they cross. That's supposed to say, it did say cross. So this line is going to be extended, boom. Where they cross here is going to be the distance to the baseline. So now I need to measure. So I'm going to measure from point C down to here, down to the baseline. And then all I need to do is convert it using a scale similar to that one. After that, you've figured out your distance. You can calculate these lines as well, or you can just find out the distance if you want. But I think the more data, the better. Any questions? All right, now that we know the steps to triangulation, we're actually going to do some triangulations. So, just better check my pen. This is my work surface, and I want to maximize how much of the work surface I'm using. So I've obtained my measurements. Now I need to make a scale drawing. So you can see 2 marks there. I marked those out at 27 centimeters apart. Why 27 centimeters, Mr. Bosch? Well, 54 divided by 2 happens to be 27, which means that 27 centimeters is 54 meters. So this would be the drawing, and this would be reality. If we take that a step further, 1 centimeter on my drawing here is equal to 2 meters in reality. So now let's put it into practice. From point A to point B, I have 27 centimeters or 54 meters. The second bit of information that I know is the angles. If you go back to the first video, you know that this angle was 80. I'm measuring from the inside up to here. I'm going to put a little mark. Now on this side, I need an angle of 56. Hi, Rosie. Rosie just came to help me out. Next step was extend the lines until they cross. Well, that might be a little bit difficult because my ruler is going to be a little bit short. Let's go there. How do I know it's a little bit short? Let's just say this isn't my first take. Okay. Oh, that's going to be pretty good. We keep going up there. I'm going to go all the way to the end of my paper. On this side, I need to go from there through there to get 80 degrees, and we can see it's going to cross up there somewhere. So once again, I need to extend it. All right. Okay, easy enough. I'm going to label my angles. This angle is 80. This angle is 56. And I'm going to label point C. And now I need to measure from point C down to my baseline. I want to make sure that that is a 90-degree angle. With that, I can do some more fun math. You guys are learning all about triangles in math and science, so you could probably tell me more than I'm telling you right now. I'm going to go through the middle, and I'll go through 90, and I'm going to make sure that that point goes through C. That line goes through point C. That makes more sense, right? So I'm right about there. So put this right on point C. Okay, it's more like this. That's okay. From there to here is 30 centimeters plus another little bit. Oh, this might be my best one yet. 30 plus 2. So I've got 32 centimeters. So the distance from A to C, or line AC, using my conversion factor, oh, this is good stuff. Okay, the drawing, I had 32 centimeters. So in reality, I need to do some calculation to get the measurement in reality. 32 times 2 divided by 1. Well, that one's so easy I can even do it in my head. That equals 64 meters. So the total distance from D, did I say AC? That should be CD, sorry. From CD, in the interest of time, I'm just going to draw that freehand. Say that's a 90-degree angle. That distance is 64 meters. So I did this earlier, and I calculated out a couple of other measurements as well. I'm actually really happy with this because it's so close to what I did with the pen and paper. CD ended up being 64.5 because I got a slightly different measurement there, and also my scale is different. That didn't affect my measurements. That would just be human error. So I've got 64.5 compared to 64. That's really, really close. AC was this side length here. AC, I've got 65.4. That's really, really close, really similar. And those lines are so close because this angle is such a steep angle. The last one, line BC, is 87. So 87 meters from there to the umbrella or to my red chair. So we can use this exact method to determine distances across a river. If this was a tree, we could determine the height of the tree, as long as you know the distance away from the tree and then the angle from where you're looking up to the top of the tree. Or you could even imagine that this is the diameter of the orbit of the Earth, very, very long baseline, and that's a faraway star. If I'm looking down this line, I'm going to see, say, this owl in the background. If I'm looking down this line, we've got a different owl in the background. Can you see the owls? Hopefully you can see the owls. So that's parallax, that's triangulation, and this is how you determine some unknown distances. Follow the steps, do some careful measurement, and you'll be just fine. Good luck.